First, let's briefly explain how each of these microelectromechanical systems or MEMS sensor work. We will start with the accelerometer. It measures acceleration by measuring change in capacitance. Its microstructure looks something like this. It has a mass attached to a spring, which is confined to move along one direction and fixed outer plates. So when an acceleration in the particular direction will be applied, the mass will move and the capacitance between the plates and the mass will change. This change in capacitance will be measured, processed, and it will correspond to a particular acceleration value. Next is the gyroscope, which measures angular rate using the Coriolis effect. When a mass is moving in a particular direction with a particular velocity, and when an external angular rate will be applied, as shown with the green arrow, a force will occur, as shown with the blue arrow, which will cause perpendicular displacement of the mass. So, similar to the accelerometer, this displacement will cause change in capacitance, which will be measured, processed, and it will correspond to a particular angular rate. The microstructure of the gyroscope looks something like this. A mass that is constantly moving or oscillating, and when an external angular rate will be applied, a flexible part of the mass would move and make the perpendicular displacement. Okay, now let's explain how the magnetometer works. It measures the Earth magnetic field by using Hall effect or magnetoresistive effect. Actually, almost 90% of the sensors on the market use the Hall effect, and here's how it works. If we have a conductive plate like this and we set current to flow through it, the electrons would flow straight from one to the other side of the plate. Now, if we bring some magnetic field near the plate, we would disturb the straight flow and the electrons would deflect to one side of the plate and the positive poles to the other side of the plate. This means that if we put a meter now between these two sides, we will get some voltage which depends from the magnetic field strength and its direction. The other 10% of the sensors on the market use the magnetoresistive effect. These sensors use materials that are sensitive to magnetic field, usually composed of iron and nickel. So when these materials are exposed to magnetic field,